In this video, we will study two color balls combination probability, but the sampling size will be 3. An urn contains 12 blue balls and 8 red balls. 3 balls are picked up at random without returning the balls to the urn. First question, what is the number of all possible outcomes or the number of elements in the sample space? So first thing we do, we number the balls to make all these balls distinguishable from each other. So we number red balls from 1 to 8 and blue balls from 1 to 12. Now even though this ball holds the number 1 and this ball holds the number 1, but this ball is distinguishable from the other one because one is blue and one is red. We can also number these balls from 1 to 20. So both ways work, and it's important to notice that in probability issues we have always to make object distinguishable. The number of elements in the sample space for the case of any order can be computed from the combination formula under the condition of withdrawing without replacement. So here we have the number of objects in the set, or the number of population 20, and the sampling size is 3. So we are picking up 3 objects out of this 20 population, and we apply the combination formula. We substitute N and R and we get 1140 possible unordered outcome. Question number 2, what are the possible joint outcomes from the standpoint of colored balls? So let B represent drawing blue ball and R represents drawing red ball. We will use the tree diagram starting with the 12 blue and 8 red. So in the first draw we may get blue or red, and the remaining balls would be 11 for blue and 7 red. Now for the second draw, again we may get B or R, but the remaining balls would be 10 blue and 6 red. Now for the third draw, we may get B and R, and the remaining balls would be 9 blue and 5 red. Now we may use this pass to know how many possible outcomes. So we may get blue and 2 red, we may get red and 2 blue, and these are all possible joint outcomes. So we may get 3 blue or 2 blue, 1 blue or 0 blue, or we may say the contrary, we may get 3 red, 2 red, 1 red or 0 red here. Now let us start categorizing them. So here we have a subset of 2 blue, 1 red, and here we have a subset of 1 blue and 2 reds. And now let's arrange them, and let's arrange this subset here. So let's turn them around, organize them and turn these around here, and now we have the sample space. So now these 4 subsets, they create partition in the sample space. We put their names, and this is the partition. Question number 3, how many 3 blue balls can be withdrawn? So we have here the urn, and now we are choosing from the subset of blue balls only. So we're choosing first element, and second and third, and now we have a sampling of 3. So what is the number of combination of 3 blue balls out of 12? That is combination of 12 taken 3 at a time, and this is equal 220 possible outcome of 3 blue balls. Question number 4. How many 2 blue and 1 red balls can be withdrawn? So here is the urn, and now we will pick up 2 blue and 1 red. So we pick up 2 blue and 1 red, and now we have a sample of 3. And now we have all possible outcome for this case, but we do not care about the order. So how many ways we can pick up 2 blue out of 12, and that is 12 combined 2. And how many ways we can pick up red out of 8 red, and that is 8 combined 1. But before we continue, let us remember the multiplication principle of 2 events or sets. If event U has U objects and event V has V objects, then the product U times V or V times U represents the occurrences of both events in any order, and this is the case of the multiplication principle where order is not important. So there are cases for the multiplication principle where order is important, such as this case number 1 here, and number 2, and number 4. But for our case, we need the case of no order, since combination implies no ordered element. So we apply case number 3 for our question. And now we have 2 sets here. The first one contains element composed of 2 blue, and the second one contains element composed of 1 red. So we want to combine these 2 blue with this 1 red using the multiplication principle. Will allow us to do that for the case of no order, and we get this product 66 times 8. So this set here has 66 elements, and each one is composed of 2 blue, and this set here has 8 elements, and each one is composed of 1 red. Now this multiplication will generate 528 elements composed of 2 blue and 1 red according to the multiplication principle here. Question number 5. How many 1 blue and 2 red balls can be withdrawn? So here we are going to pick up 1 blue only and 2 reds, and now we have a sample of 3. So we have all these possible outcomes, and we do not care about the order. So in how many ways we can pick up 1 blue out of 12, and that is combination of 1 out of 12, or 12 combined 1. And in how many ways we can pick up 2 red out of 8, and that is 8 combined 2. Now again we apply the multiplication principle in order to combine 1 blue with 2 reds in any order, and we get 12 times 28, and we have here 336 possible outcomes for the case of combining 1 blue with 2 red. Question number 6. How many 3 red balls can be withdrawn? So we are picking up first red and second red and third red, and now we have a sample of 3. And now what is the number of all possible combination of 3 red? So we are picking up 3 red out of 8 red, and that is 8 combined 3, and this is equal to 56. So now we represent the sample space with 1140 outcome and with all these events. So the first one, picking up 3 blue balls with 220 possible outcome, and the second one, 2 blue and 1 red with 528 outcome, and 1 blue only with 336 outcome, and 0 blue or 3 red with 56 possible outcome. Question number 7. What is the probability of drawing 3 blue balls? So as we know, we divide the number of elements in this event, which is 220, over the number of elements in the sample space, and we get 0.19. Question number 8. What is the probability of drawing 2 blue and 1 red? So here we have 2 blue or 1 red. So the question can be asked in different ways. Somebody may ask what is the probability of drawing 2 blue only, and somebody else may ask what is the probability of drawing 1 red only. So both will refer to the same event with possible outcome of 528. So we divide that over 1140 and we get 0.46. Now next question, number 9. What is the probability of drawing 2 red and 1 blue? So here we have the possible outcome 336. We divide that over 1140 and we get 0.29. Question number 10. What is the probability of drawing 3 reds only? So possible outcome is 56. We divide it over 1140 and we get 0.049. Question number 11. What is the probability of drawing at least 1 blue? So here we have the sample space and we need to pick up at least 1 blue, which means the minimum number of blue balls would be 1. So we may pick up 1 blue or 2 blue or 3 blue. And the union of all these events is going to give us the event of picking at least 1 blue. So these 3 events are disjoint, and that means that their probability is the sum of their individual probability. So the probability of picking up 1 blue plus the probability of picking up 2 blue plus the probability of picking up 3 blue. So for this event we have 336 possible outcome divided by 1140 will give us its probability, plus for the second event, and second event has 528 possible outcome, we divide that over 1140 to get its probability, and we do that for the third one, which has 220 possible outcome, and we get finally 0.95 or 95%. Question number 12 is the same as the previous question, but we will answer it in a different way. So what is the probability of drawing at least 1 blue? So this is the event of picking up at least 1 blue, and we notice that there is a complement event for it, which is picking up 3 reds. So the probability of at least 1 blue equal 1 minus the probability of picking up 3 reds, and that is 1 minus the number of elements in this event is 56 divided by 1140 equal 0.95. Question 13. What is the probability of drawing at most 1 blue? So at most 1 blue, it means the maximum number of blue balls should be 1. So we may pick up 1 blue ball or no blue ball. So it means 3 red balls. So these two events will create the event which is at most 1 blue. So these two events are disjoint, and the probability of this event is equal the sum of its disjoint events, which is the probability of 1 blue plus the probability of 0 blue, and that is equal to 336 for the first event over 1140 plus 56 for the second event over 1140, and this is equal 0.34. Question 14. What is the probability of drawing 2 red or 2 blue? So this is the event of drawing 2 red, and this is the event of drawing 2 blue. But we have to pay attention for this word or. So or means this event will take place if we pick up 2 red or if we pick up 2 blue. So these two events are disjoint, and their union would give us the event we are looking for. So the probability of this event is the sum of the probability of its disjoint event, and that is 336 for the first one divided by 1140 plus 528 for the second event divided by 1140, and this is equal to 0.75. Question 15. What is the probability of drawing exactly 2 red and exactly 2 blue? So here we have to emphasize on this word here, and that is and. So this event will take place if we get 2 red and 2 blue at the same time. So this is the event of picking up 2 red, and this is the event of picking up 2 blue, and we notice that their intersection is a null set. So the event of 2 red and 2 blue means the intersection of the event 2 red and 2 blue, and their intersection is a null set, so there is no any mutual element between them, and that means the probability is 0.